So these steps are nearly identical to what they were on your 6.4 notes, which is when we graphed quadratics when a was equal to 1. The only thing that's different is how you find your zeros today. So step 1 is still the same. We find our axis of symmetry in our vertex. That's what we did very first in this unit. So we do our negative b over 2a. We plug that in to solve for y. We graph that and draw our axis of symmetry. Okay, step 2, we are going to find our zeros. We can either factor like we did yesterday or use the quadratic formula like we did yesterday. It is up to you. Step 3 is to find our y-intercept. Our y-intercept should always still just be c. So always be c in standard form. And then we put it all on our graph. So those are our 3 steps. 1, 2, 3. Put it all on your graph. This is just all of our like extra reminders. I put the quadratic formula on here. I put your magic X on here. I put your table of positives and negatives on here. All that jazz. So we've got 2 examples on the back. Because we have 2 options, we can factor or use the quadratic formula. We're going to do one example one way and one example the other way. So go ahead and flip this over. We've got 2 examples. Okay, 4x squared minus 16x plus 7. This right here would be a point on your test to answer these. What's my a value? 4. Thank you. What's my b value? Negative 16. Okay, somebody other than Miles and Soph, because I know they're right here next to me and they got it. What's our c value? 7. Thank you, Meharan and Sophia. Okay, so that right there is a point on this question on your test, is writing down a, b, and c. Okay, to find our axis of symmetry, we do x equals negative b over 2a. Plugging in our b value, negative 16 over 2 times a, which is 2 times 4. A negative is positive, so that's positive 16, over 2 times 4 is 8. So we've got 16 divided by 8, which is 2. Okay. That right there, another 2 points on this question. We plug it all in, that's a point. Solving it out, that's a point. So once we get that as our axis of symmetry, we can go ahead and graph it. It's a vertical line at 2. You're going to want to be very careful on your graphs on these because things are going to be super close together. That's just the nature of these graphs. Okay, that 2 is also the x of my vertex. Okay, now that we have that, we can plug that 2 in for x in our original equation, and that'll give us our y value. So instead of 4x squared, we're going to have 4 times 2 squared. I was checking to see if we were still in a severe storm warning, and it just popped up with that really loud video. I'm sorry. Grab a note sheet from over here.
I wonder how all the other students are going.
Okay. From there, so we've got minus 16x, so it's going to be minus 16 times 2. And then we've got plus 7. Okay, so we're plugging in 2 for x. We can throw all of that into a calculator. we've got 4 times 2 squared minus 16 times 2 plus 7. And I get negative 9. Okay, so that means my vertex is at 2, negative 9. I can go and graph that. So I already have the 2. Come down here to negative 9, put a point. Okay. Any questions about finding the rest of our vertex? Okay. So in that case, we are ready to move on to our zeros. So our zeros are exactly what we did in yesterday's assignment. So we can choose, when we've got a number in front of x squared, we can choose to use the quadratic formula, or we can choose to factor. We're going to do the quadratic formula on this first one. We'll factor on the second one. So for this first one, we'll use quadratic formula. And then you can choose whether you always use quadratic formula, which is, I think, what most of us have been doing, or always factor. X equals negative b. So that's going to be negative 16 plus or minus the square root of b squared. So that's going to be negative 16 squared minus 4 times my a value is 4 times my c value is 7. And then that all goes over 2a, which is 2 times 4. Okay. Negative 16 is positive 16 plus or minus the square root. We can put this whole, everything underneath the square root in a calculator. Negative 16 squared minus 4 times 7 is 144. So 16 plus or minus the square root of 144 all over 2a. So that's 2 times 4, which is 8. Okay, what is the square root of 144?
12.
12. So now we've got 16 plus or minus 12 over 8. And I'm going to come use this space down here to do the rest of this. So I'm going to split into my 2. It's going to be 16 plus 12 over 8 and 16 minus 12 over 8. (16 plus 12 is 28. Yeah, 28 over 8. You can divide 28 and 8 both by 4, which is going to give me 7 halves. (16 minus 12 is 4. And then 4 is half of 8, so 4 over 8 is the same thing as 1 half. So I get 7 halves and 1 half.
Isn't the y-intercept all 1? always set the C value.
You got it. Okay, let's talk about how we graph fractions. So fractions, for our zeros, we're going to end up getting fractions for all of your zeros today. They are going to be on your x-axis. We know where 1/2 goes. 1/2 is halfway in between 0 and 1. I'm going to zoom into this graph. So 1/2 is going to be halfway in between 0 and 1. It's going to be right there. Obviously, these graphs aren't going to be perfect. Just do your best. As long as they're between the correct two numbers, you'll be fine. Then 7/2, if you in a calculator put 7 divided by 2, you're going to get 3.5. So if you want to put it into a calculator to get yourself a decimal, you can. 3.5, so we need to go past 3 before 4. Should be right there. Way too much out. Yes, so in between 0 and 1, and then in between 3 and 4. Because 7/2 is 3.5, and 1/2 is 0.5. And then the last thing is our y-intercept. Our y-intercept is always our C value. So in this one, it's 7. And if you want to put a note to yourself that says always C, always equal to C, so you remember when you look back, I would. So that's going to get graphed on my y-axis at 7. And then that can also get reflected. It's currently 2 to the left of my axis of symmetry, so I reflect it 2 to the right. I'm going to tell you right now, all your graphs today are going to be tall and skinny or short and skinny. But for the most part, they're going to be pretty narrow. So we'll connect those 5 points. We're going to pay way more attention to your answers over here and to the fact that this is in the general correct area. Is it leaking? Okay. That it's in the correct general area than your graph being perfectly symmetrical. It's raining outside, guys. But I watched a live video of the news this morning, and they said that the more rain we get, the less chance of tornadoes there is, because it messes up the system, and the more it storms during the day, the less chance there is for tornadoes later. But yeah, we're in Kansas, so who knows what's going to happen? There's going to be an earthquake or something.
The weather here is unpredictable.
It is. All right. Any questions right now? All right. We're going to do one more, and then you guys will have the rest of class and our work day tomorrow to work. So we've got 9x squared plus 18x plus 5. We've got our A, B, and C values. My A value is 9. My B value is 18. And my C value is 5. Okay. To find our axis of symmetry, we always do negative B over 2A. So it's going to be x equals negative B over 2A. Negative B would be negative 18. And then 2A is going to be 2 times 9. So negative 18 over 2 times 9 is 18. And then anything divided by itself is 1. So negative 18 divided by 18 is negative 1. And we can graph our axis of symmetry at negative 1. That is the x of my vertex, and I can go ahead and plug it in. So it's going to be 9 times negative 1 squared plus 18 times negative 1 plus 5. 9 times negative 1 squared plus 18 times negative 1 plus 5 gives me negative 4. So my vertex is at negative 1, negative 4. Negative 1, sorry, negative 4. There we go. Okay. I told you guys I was going to factor this one. If you do not want to factor and you want to tune me out and do quadratic formula on your own and meet me at the end, you can. I'm going to factor it. So I'm going to find two numbers that multiply together to 9 times 5, so that's 45. So we need to multiply to 45. And we need to add together to 18. Those two numbers are 3 and 15. 3 times 15 is 45. 3 plus 15 is 18. So then I'm going to take my 18x and I'm going to split it up into 3x and 15x. So I've got 9x squared plus 3x plus 15x plus 5. From there, out of my 9x squared and my 3x, I can pull out a 3x. 9 divided by 3 is 3. I still have an x because x squared take away one of them. I still have 1. And then 3x divided by 3x is 1. Anything divided by itself is 1. You have to have that placeholder 1 there. Then out of 15x and 5, I can divide a 5 out of both of those. 15x divided by 5 is 3x. 5 divided by 5 is 1. So then my factored form, this 3x plus 1 matches. So that's part of it. And the other part is this 3x plus 5. To find your zeros, we have to set each of those equal to 0. You can do that work in your head or you can do it on paper. I don't care about seeing it. I trust that you can do it in your head. But if we set 3x plus 1 equal to 0, we'll subtract 1. We'll get 3x equals negative 1. We'll divide by 3. And we'll get x equals negative 1/3 for one of them. For that 3x plus 5 equals 0, we would subtract 5 from both sides. Get 3x equals 0 minus 5 is negative 5. And then divide by 3. We're going to get negative 5/3 for our other one. So our two zeros are negative 1/3 and negative 5/3. If you did the quadratic formula, you should have gotten the same thing. I know we might not all be done doing the quadratic formula yet. That's what we chose. But if you're going to do the quadratic formula, you're going to get the exact same things. Okay, from there, we need to graph those. So again, graphing fractions, kind of tricky. Negative 1/3 is negative 0.33333. Negative 5/3 is negative 1.6666667. So it's going to be in between. Negative 1/3 is going to be in between 0 and negative 1, but closer to 0. And then negative 5/3 is going to be in between -1 and -2, closer to -2. As long as you get them between the right two numbers, or even like close to that, you'll be fine. It'll all work. Because we're going to check here, because obviously we wouldn't be able to check your graph from that. And then the last thing is our y-intercept. Our y-intercept is always c, so it is 5. So we'll graph that at 5. It's 1 to the right, so then we go 1 to the left. We'll have this really tall, skinny U. The bigger this number in front of A is, the taller or the skinnier it gets. Just FYI. Okay. No. So like if the negative 5/3 is first. Is that what you're asking? Yeah, it doesn't matter what order these go in. These are interchangeable. Okay, cool. Any questions right now? Okay, is it a lot? Yes. Is it manageable if you break it down piece by piece? Yes. You guys showed me that you can find your zeros by either factoring or doing the quadratic formula yesterday. And you showed me from 6.1 that you can do this. So you just got to think about doing them separately. And then if you need help getting it put together on the graph, we can help you. Okay.